Double Slit Experiment. This experiment comes from physics and was first performed by Thomas Young to understand how light behaves. A beam of light is directed toward a barrier with two narrow slits, and behind it is a screen that records the result. Instead of forming two simple lines as expected, the light creates a pattern of multiple bands, which shows that it behaves like a wave. What makes this experiment unusual is that when scientists try to observe which slit the light passes through, the pattern changes and starts behaving like particles instead. It suggests that observation itself can affect the outcome, making it one of the most important experiments in understanding the nature of reality. Michelson-Morley experiment. This experiment was designed to detect the presence of something once believed to fill space, called the ether, which was thought to carry light waves. Scientists Albert Michelson and Edward Morley used precise instruments to measure the speed of light in different directions. Surprisingly, they found no difference at all, no matter how the experiment was oriented. This result challenged existing theories and showed that light does not need a medium to travel through. It later became a key piece of evidence that helped shape modern physics, especially Einstein's theory of relativity. Cavendish experiment. This experiment was carried out by Henry Cavendish to measure the gravitational force between objects on Earth. Using a delicate setup with suspended weights and a torsion balance, he was able to detect the tiny attraction between masses. From this, he calculated the value of the gravitational constant and even estimated the mass of the Earth. What makes this experiment remarkable is its precision, achieved with very simple tools. It showed that gravity could be measured in a laboratory, not just observed on a large scale. Rutherford gold foil experiment. This experiment was conducted by Ernest Rutherford to study the structure of the atom. He directed a beam of alpha particles at a thin sheet of gold foil and observed how they scattered. Most particles passed straight through, but a few were deflected at large angles, and some even bounced back. This unexpected result led to the discovery that atoms have a small, dense nucleus at their center. It completely changed the earlier model of the atom and became the foundation for modern atomic theory. Stanford Prison Experiment. This experiment was carried out in 1971 to study how people behave in positions of power. Volunteers were randomly assigned roles as guards or prisoners in a simulated prison environment. Within a short time, the guards began to act harshly, and the prisoners showed signs of stress and helplessness. The situation became so intense that the experiment had to be stopped early. It revealed how strongly human behavior can be influenced by roles and environments, rather than just personality. Milgram experiment. This experiment was designed to understand obedience to authority. Participants were instructed to deliver electric shocks to another person whenever they answered a question incorrectly, although the shocks were not actually real. Despite hearing what seemed like pain from the other person, many participants continued because they were told to do so by an authority figure. The results showed that ordinary people can follow harmful instructions under pressure. It raised important ethical questions and changed how psychological studies are conducted. Pavlov's dogs experiment. This experiment was conducted by Ivan Pavlov to study how learning happens through association. He noticed that dogs would start to salivate not just when they saw food, but also when they heard the footsteps of the person feeding them. He then paired a neutral sound, like a bell, with food repeatedly. Over time, the dogs began to salivate at the sound alone, even without food. This demonstrated classical conditioning, showing how behaviors can be learned through repeated associations. Schrödinger's cat. This thought experiment was proposed by Erwin Schrödinger to explain the strange nature of quantum mechanics. It imagines a cat placed in a sealed box with a mechanism that has a random chance of releasing poison. Until the box is opened, the cat is considered both alive and dead at the same time. The idea highlights how quantum systems can exist in multiple states until observed. It is not a real experiment, but a way to understand how uncertain and complex the microscopic world can be. HeLa cells discovery. This case began when cells were taken from a woman named Henrietta Lacks during medical treatment in 1951. Unlike normal human cells, these cells continued to divide indefinitely under the right conditions. They became the first immortal human cell line and have been used in countless scientific studies. Their unique ability to survive and reproduce made them essential for medical research, including vaccine development.
At the same time, it raised important questions about consent and ethics in science. Foucault pendulum. This experiment was created by Léon Foucault to demonstrate the rotation of the Earth. A large pendulum is suspended and allowed to swing freely over time. As the Earth rotates beneath it, the direction of the swing appears to change when observed from the ground. This provides visible evidence that the Earth is rotating, without needing to look at the sky. It is simple in design, but powerful in what it proves, making it a classic demonstration in science.